Hi everyone, welcome to the video on data visualizations. In today's lecture, we're going to talk about some of the best practices when we're creating visualizations for data and we're trying to extract information out of the data. Data visualization is a process of displaying data. Often the data that we use in this case is given in large quantities. We want to be able to create visualizations that are not only meaningful in terms of the insights, but they also support better decision making. So with the help of these visualizations, we are trying to make sense out of large quantities of disparate data, not only for gaining competitive advantage, but also for surviving in it, because these days attention spans are really small and people want efficiency more than anything. So the purpose of the data visualization should be not only to give insights as quickly as possible, but also in a way that grabs the attention of the audience. In this slide deck, which has been provided to you on Canvas, we're going to walk through some of the types of data visualizations that we can create using Excel. And in another video, I'm going to introduce a software called Power BI to you. Since this is just an 8-week course, we won't be able to work a lot on Power BI, but I still wanted to introduce you to the software and all the capability that it has, being a free software, and how useful it can be to create data dashboards for your businesses. There's a usual and common misconception that data visualizations are only fancy charts that are appealing to the eye, but visualizations can also be nicely categorized tables that summarize data in a way that a chart may sometimes not be able to do. So we're not going to restrict ourselves to just charts. We're also going to go over some of the best practices when you're creating a summary table out of your data, and we're also going to use a very useful tool in Excel, which is called the pivot table, and learn how we can manipulate data using a pivot table in order to get different views of the same chunk of data in order to help us with the decision-making process. Let's start off with some of the best practices when we are trying to create visualizations. The first and foremost best practice that we need to be following is something called the data ink ratio, which measures the proportion of the data ink compared to the total amount of ink that is used in a table or a chart. So the basic idea of the data ink ratio is that you should be able to clearly see the information that the table or the chart is trying to convey, which means that you need to get rid of unnecessary grid lines that don't serve a purpose. In addition to that, a simple rule that probably you should follow is that the data ink should be higher than the non-data ink, which means that if you have color representing numbers in your table or your chart, then that color should be more outstanding than the rest of the chart or the table that is not providing any insight. So for example, if we take a look at this chart over here, which is a line graph of sales by day, the background grid lines, horizontal, although they are telling us about the level of sales for each day, they might not be as necessary in this case if we're we don't exactly care about the exact number of sales. So in this case, getting rid of the grid lines is going to create a chart which would be easier to just see the variation in the sales by day. Similarly, if we take a look at this table over here, the grid lines on the table do help us separate the rows and columns from each other, but if the same table is represented without the grid lines, it would be much easier to focus on just the information given out by the numbers as opposed to being distracted by the unnecessary grid lines. Next, we're going to talk about tables. So as I mentioned earlier, data visualizations are not just charts. Tables can also be a powerful tool for summarizing and viewing data from different angles and sorted out in different ways. Sometimes tables are actually more useful than charts, and those are the times when specific numeric values are needed, or you need to make precise comparisons between values, or sometimes when the values have different units and different magnitudes. You could also do a combination of both charts and tables in one single figure. An example for that is given on this slide over here, where the chart represents the trend by month in both revenue and cost, and the table beneath the chart gives you the option of reading off the exact values for revenue and cost, and then refer back to the chart if you want to. So a combined line chart and a table can sometimes give out more information if you're interested in precise comparisons and you want to refer to specific numeric values. When we're comparing different types of table design, this slide over here shows a very good comparison of the different layouts that you can choose to represent your table in. So all the four designs are giving you the exact same information, but out of all the four, design D is probably the most simple yet the most effective, and hence the preferred design out of all the four designs over here. The right number of digits and decimals need to be used in your table. So for example, in this case over here, since we're dealing with thousands of dollars, adding decimal points to your figures may not increase the value of your table. Instead, it might just create a type of clutter that may distract you from the actual numbers. One thing that you should also remember while designing your tables and charts is that the alignment within your table and chart should be consistent, and usually the preferred alignment that is generally agreed upon is having your numbers right aligned so that it's easier to compare the magnitude of those numbers, and having your text left aligned so that it's easier to read them off. When we're talking about tables to summarize data, a useful type of table for describing data of two variables is something that we call cross-tabulation. Cross-tabulation provides a tabular summary of data for two variables. To illustrate how useful cross-tabulation can be, we're going to use the pivot table option that is available in Microsoft Excel, and I cannot emphasize this enough as to how useful a pivot table can be when you're trying to analyze data. Let's use this example over here to demonstrate that. So this example is data from Zagat's restaurant review, and data is available on the quality rating, meal, price, and the usual wait time for a table during peak hours from a sample of 300 restaurants in Los Angeles. So with the help of a pivot table, we're going to look at how easily we can view the data in different types of sorting and in different types of to answer different types of questions from the data set. So one of those views is this cross-tabulation of quality rating and meal price. So on the rows over here, you see the quality ratings: good, very good, excellent. And here under the columns, we have created different buckets based on the meal price range. And from this table over here, because of the cross tabulation that we did by slicing the data based on ratings and meal price, we're easily able to see that the greatest number of restaurants in the sample have a very good rating and a meal price which is between the range of $20 to $29. So this second column here represents a major chunk of the data set under which our data falls, and the right and bottom margins of the cross tabulation are giving us the frequencies of quality rating and meal prices separately. So over here, if we look at this totals column, we can easily tell that the highest number of restaurants in our sample had the very good rating, and this bottom row over here tells us that most of these restaurants fell in the price range of 20 to 29. I would recommend that you download the Excel data file that is provided to you on Canvas and follow the steps which have been given to you as a part of these slides. If you just scroll down to the bottom of the slides, there is some explanation about the slide, and you're going to find steps about how to create pivot tables from scratch in Excel. As a practice, I would recommend you follow these steps and create the pivot tables that are shown in these slides on your own so that you get an idea of how easy it is to create these views in Excel. Next, we're going to talk about charts. Charts are a common visual method to display data, and I'm going to just quickly touch upon all of these different types of charts that you're going to come across in the chapter as well in the slides. So these are the most commonly used charts in Excel, but there are definitely more than this list over here. So if you have time and you want to get some practice, you can try to play around with the data that has been given to you in creating some different types of charts. But when you're creating these charts, one thing that you should remember is that your charts should be readable on their own, which means that the axis on the chart should be labeled correctly along with the units. So if you have dollar values, it should tell the currency in which it's being measured. Is it US dollars, is it Canadian dollars, or is it some other type of currency? Or if you are dealing with some other types of measurements, then the units of those measurements needs to be stated as well. Similarly, your charts should always have a title, which should represent what the chart is showing. And sometimes a simple footnote at the end of the chart also helps in clarifying what the source of the data set is and what was the time frame in which the data was collected, so as the reader can make their decisions based on that additional piece of information that you're providing about the source and the time frame of the data. So this list over here represents some of the more commonly used types of charts. The first one is the scatter chart, or sometimes we call it the scatter plot as well. It's extremely useful in trying to find out the relationship between two quantitative variables. So a typical scatter plot looks something like this. In this one here, we also have a trend line which has been added to the scatter plot, but even without the trend line, the scatter plot is very useful in demonstrating the pattern of the data set, which shows that as the number of commercials increases, the sales value, which is variable number 2, also increases. The steps to create these scatter charts and other types of charts throughout the video that I'm going to talk about have been provided to you in the notes section of these PowerPoint slides. So if you scroll down to the notes section of these slides, they're going to give you some more information about the data that is being represented here, and also provide you with the steps that you can follow in order to replicate these charts on your own. Another common type of chart is a pie chart, which we see a lot in reports, and it's really easy to generate as well in Excel. However, they do look visually appealing, but most of the experts have some controversial views about pie charts as a part of giving information that is insightful about the data. So the problem with pie charts is they are considered inferior to other types of charts, such as a stacked chart or a column chart or a bar chart. The reason for that is that making visual comparisons in a pie chart can be much harder. So for example, if I look at this pie chart that is in front of me, it would be very hard for me to guess whether Smith had a higher share or Davis had a higher share, because both their slices of the pie look very similar to me, and I might not be able to tell which one of those two is getting the higher share of the pie. Because of that reason, experts usually believe that pie charts should not be used, or even if they are used, they should be used as a complementary chart and not as a standalone chart. So adding a table with the pie chart or adding a bar chart along with the pie chart clarifies the reader's questions about these comparisons. Another type of chart which can be very useful is a bubble chart. A bubble chart is basically a two-dimensional way of creating a visualization with 3 variables. So it's like a preferred alternative to a 3D chart, because sometimes 3D charts can be too much on the eye. So a bubble chart is preferred over a 3D chart. They're very easy to create in Excel, and if you follow these steps, the data has already been provided to you in Canvas, and you can replicate this bubble chart to see what the ratio of billionaires per country is like, and how much are they actually worth based on the country, as well as the number of billionaires in that. Another type of chart that I'd like to talk about and highlight that is a part of this PowerPoint deck is heat maps. So heat maps are sort of like graphs that use different shades of color to indicate magnitude. So in this example heat map that I have, if this was just simply a table and it had not used all the conditional formatting based on colors and highlighting, it would be very hard to tell what the trend for each of these rows of data is like. But because of the color coding and the use of colors in a way to represent the increase in growth or the decrease is very useful in identifying what the trend looks like for each of these cities. Now, sometimes, again, like the magnitude might not be as easily conveyed just by the use of color, so we can also add additional features such as a spark line, which demonstrates the trend with the help of a line for each of these rows, so that you can quickly look at it and make a decision about what you want to do with each of these data sets. You should go through the remaining slides in the deck in order to know more about how to create these different types of charts, the ones that I'm not covering in the lecture as well, because for these charts to really give information, you need to be able to practice with them and learn how to create them from scratch. So practicing with the example data files that have been given to you and following the steps that are provided to the notes of these PowerPoints is extremely important. I'm just going to talk about some of the things that I want to highlight. We did introduce scatter plots earlier in the start of this video, but what I wanted to show you was this advanced scatter plot that has been created for New York City's rent data. And it's not just one scatter plot, instead it's a combination of different scatter plots for different variables. And this is called a scatter plot matrix. Usually we create a scatter plot matrix for data where we have multiple variables, not just two, and we want to see the relationship between all the variables with each other. So for example, if I enlarge this scatter plot matrix over here, the way you're going to read the scatter plot matrix is that the first row over here tells you what is going to be on the x-axis of each of these scatter plots. So if I take column number 1, the x-axis is going to be common for all these charts in column number 1, which represents median rent. On the other hand, the rows tell you which variables are on the y-axis. So for row number 2, all these plots that are on row number 2, the y-axis is the same, which is college graduates. So if I want to compare the relationship between college graduates and the median rent, it looks like they have an increasing relationship. Whereas if I want to compare the commute time and poverty rate, it looks like it might be increasing, but it's slightly more random than this chart over here that I discussed earlier. So a scatter plot matrix is particularly useful when we're trying to run a regression analysis, and usually when you're trying to identify which variables could be related to each other, this is the first chart that we create in that type of analysis. Unfortunately, the sad news is that scatter plot matrices are not easily drawn in Excel, so you might not be able to do this in Excel itself, and you need a more powerful tool such as Tableau or R or SPSS or SAS, Jump Pro. All of these other tools have the capability to create a scatter plot matrix of all the variables in your data set, just not Excel. There are plenty of other types of charts that are also available for you to create based on the data that you're trying to investigate. One of those charts is called a parallel coordinates plot. At first, this plot might seem too complex, but if you actually understand what the data is trying to show you, it might be very intuitive to look at. So a parallel coordinates plot, what it does, it includes different vertical axes for each variable. So in this example over here, I have 3 variables that are being compared to each other. Each observation is represented by drawing a line, and the connection of those lines shows how each observation has different values for each of those 3 variables. The height on the line of each variable represents the value that the observation has taken for the variable corresponding to that vertical. So for example, this parallel coordinates plot, which is taken from a baseball data set, represents data for 10 players who play first base and 10 players who play second base. So for each player, the leftmost vertical axis plots his total number of home runs, which is represented by this HR axis over here. The center vertical axis represents the total number of stolen bases. The second vertical axis here labeled SB, and the rightmost vertical axis plots the player's batting average. The two colors that are represented here, they differentiate the first base player from the second base players. So the first base players are in blue and the second base players are in red. Now, with the help of the parallel coordinates plot, we can make several interesting statements. So for example, this sample of the first base players tends to hit lots of home runs, but very few stolen bases. So you see the lines in blue, they have a high magnitude of home runs, but the magnitude of stolen bases is much lower, which is why their average comes out to be somewhere in the middle. On the other hand, players at second base are often faster and more agile in order to handle the defensive responsibilities of the position. Here you can differentiate the categorical values using the color, and it was helpful in identifying the common traits across the multiple dimensions, such as the first base and the second base players. Another useful chart that can be created in Excel and is quite advanced is what we call a tree map. So a tree map is useful for visualizing hierarchical data along multiple dimensions. What you see on the slide right now is an example of smart money maps market of. This example that you see is Smart Money's map of the market. What you see over here is that each rectangle represents one company, and the color of the rectangle represents the performance of the company's stock. So if the color is green, the stock has been performing well, and if the color is red, then the stock has not been performing so well. And furthermore, the market sector is also shown. So for example, here you can see all the technology companies are grouped together, all the financial companies are grouped together, all the healthcare companies are grouped together. So it's very easy to tell how each of these rectangles compare to the other rectangles within their respective industry. The size of the rectangle represents the market cap, so that's one additional dimension that you're trying to show using this visualization technique, which is why it's really good for comparison. And you can highlight a typical rectangle here to get in more details about that company's performance. In this case, the rectangle that is highlighted is Apple's stock, and although it's not shown here, but Apple has been doing really well compared to its peers in the technology industry. Next, we're going to talk about data dashboards. Data dashboards are an effective way to dynamically represent data. A dashboard is a visual representation of a set of key business measures. It's derived from the analogy of an automobile's control panel, which displays speed, gasoline level, temperature, and so on. What's important about data dashboards is that they provide summaries of key business information to help manage a business process or a function. So data dashboards will update on their own as more information is loaded into the data that the dashboard is taking the data from. Although data dashboards may not be created on Excel itself, but there are plenty of packages that can be used as an add-on to create data dashboards. One of them it's this commonly used one is called the Excel Miner, XL Miner, and it's spelled that way. Another one, as we all know, is Tableau. Tableau is a very common tool these days that companies use in order to create these data dashboards that update frequently. But Tableau is quite expensive, and the industry trend these days is to move towards more open source software, which is why in the next video we're going to talk about the capabilities of the software called Power BI and its ability to create these data dashboards.